Are we good here? 85%. Can someone take a guess? Who's brave? Who can take a guess about what that number, that percentage has to do with AI? Anybody feeling brave? That's very close. The answer was who is not using it. This has to do with people who are using it, and it's actually a bit of a scary stat. This isn't changing. This is. Sorry, technical difficulties. We gave away the punchline, but that's okay. We're going to do this in real time. The answer is, of all the projects that are being initiated, approximately 85% of those are not leading to a production outcome. They're basically failing. That's not to say that they can't get a prototype working, they don't have something running in the cloud. It means 85% of all the AI projects that are started don't make it to production where they can actually drive value. It's a pretty scary stat, and it's actually slightly low according to MIT, who had a similar report come out 2 weeks ago. They're putting this figure closer to 95%. This is probably contributing to a lot of the noise we hear in the market. Is AI going to have value? Are we seeing a hype cycle? Where is the payoff? Is this just a bunch of companies sending money around? And we're going to spend a couple of minutes today proving why, although this is very high, the ones who get through that filter are actually seeing incredible success. The number one reason why that number is so high, it's probably not surprising. It's not because there's a shortage of investment. It's not because there's a shortage of ambition or use cases. It's actually access to data. That doesn't mean they can't find the data or they can't qualify the data or ingest the data. It's a very high-level statement that the number one challenge has to do with data. There's about 100 different reasons that data is the obstacle, but that's the category that's creating the most issues. And if we look at what goes into AI, this is a very big simplification. We're leaving out the human element and a lot of other things, but there's essentially three things. So there's the compute. So that's your amazing NVIDIA GPUs or whoever's GPUs you're using, your networking, your data center. That's software, is including the model itself, but also all the tooling that data scientists, analysts, and engineers are using. And then, of course, there's the data. So if we're seeing that data is causing all of this failure, where does that place the value of data? Essentially, it's the fuel for AI. So if we think about the AI factory, something from NVIDIA, as the refinery for data, then data is the raw materials that goes into that factory. And if those raw materials are not in the right format or are not governed or classified or secured, they're going to cause issues. So today, we're going to talk about ways to overcome that. My name's Ryan. I work at NetApp. I have a very great team here today. We've got a booth out there if you want to come talk afterwards. But if you can remember one thing for today, I'm hoping it's how to look at your data estate differently so that you can get faster time to value for AI. We're hearing this as a very loud request from most of the customers we work with, is that they've got ambition, they've got data science teams, engineers, analysts, they've got decades of data, they've got access to high-quality GPUs, whether it's on-prem or in the cloud, they've got the best models that they're pulling down or they're building their own, but they're still facing this big question about where is the ROI. And so today we're going to look at data slightly differently and hopefully answer some of those questions. If you're wondering who NetApp is founded in 1992, right around the same time in Silicon Valley that another company was being founded around a table at Denny's. NetApp is a Fortune 500 company. We've got the pleasure of serving almost 40,000 business customers around the world by 12,000 plus employees, 90 offices across 30 countries. Because we started in 1992, that's given us a unique vantage point on the evolution of data. We've seen a bunch of different eras, and there are three commonalities across all those eras. So if we talk about .com, the big data era, the big move to the cloud, and now the AI era, we're seeing three things that have been consistently increasing throughout that journey. It's the amount of data, the complexity of managing that data, and the cost. So because we got to see all this, we were the first to understand some of those challenges and introduce ways to overcome them. For example, we were the first to unify file and block workloads, as well as unifying structured and unstructured data. We were the first to launch a data fabric strategy that allowed you to have the same operating system to manage your data across all your environments, whether that's on-prem, at the edge. And then we built on that to become the first storage vendor that appeared in all three major hyperscalers, Azure, Amazon, and Google, as a first-party service. And now that positions us for today, helping enterprise, commercial, public sector, education customers across the world finally actually turn that very important cost, which is storing your data, into a highly valuable asset that can power the evolution of your business as you start ingesting AI. But don't just take it from us. We've got some great friends. This is Jensen, founder and CEO of NVIDIA. Last year at GTC, he put out a pretty amazing stat, which is that nearly 50%, well, he said half of the world's files, it's about 46%, but we'll take that, run on NetApp. So that's on-premise file data. That is an amazing amount of data that we've been able to help our customers manage, scale, and turn into value, which has given us a unique way to look at managing that complexity. And NVIDIA and NetApp are not just friends who have good marketing messages, we're technology partners as well. In fact, I wish I could play it for you, but just yesterday, Jensen and our CEO were on stage at our customer event that's happening right now in Las Vegas. If you happen to remember my name, or if you go to NetApp's homepage, I just posted this on LinkedIn. There's a 20-minute fireside chat with Jensen and George, our CEO, which talks about some of the newest announcements that we have. It's worth a watch. So again, this is a worldwide partnership that has deep technology integration. So we are certified to run NVIDIA's largest AI factories called SuperPods. We're an NVIDIA cloud partner. I'll spare you all the details, but it gives us a unique vantage point to work alongside NVIDIA and help customers across the world, again, make sense of this extremely complicated data estate. So back to that first question, how do you get faster time to value out of AI? There's basically three categories that you've got to look at. So the obvious one is the first, which is actually modernizing the storage itself. It has to be higher capacity, a lot faster. So the stuff that we've been using for decades to run, Hadoop databases, storing emails, all that stuff, that storage is great, serves a very important purpose, and still will for many years to come, but it's not going to be good enough when you're using AI, and we'll get into why in a moment. The second category is the ability to manage your data wherever it is. So if you're in one cloud or multiple clouds, on-prem, collecting data at the edge in real time, you've got to have a way to make sense of all that data, no matter where it lives. And the third one, this is the important one. This is actually being able to classify the data, govern the data, make sure that you're not putting your customers' social insurance numbers into your AI models, make sure you don't have credit card numbers coming out in plain text on your website, making sure that you can secure that data and govern it all the way through your AI pipeline. You can imagine investing, X millions of dollars into an amazing AI model only to have a major PR fiasco because you didn't have the right governance in place. So we've just talked about all the ways that AI projects are failing, and I don't want to give the impression that we don't have some amazing success stories. Does anybody recognize this person here? It's a Montrealer. So that's Lance Stroll, who is one of the drivers of the Aston Martin Formula One team, who we are lucky enough to be a longtime technology partner with. So before we get into some of the ways to actually overcome these challenges, I wanted to highlight a couple of success stories. Lance is in charge of getting this car around the track faster than the competitors. Now you might think, racing cars, that's a great driver in an amazing car, and they just have to use their skills to get that thing around the track. That's how it used to be. But now it's a very complex technological endeavor that has hundreds of people and hundreds of millions of dollars per year spent on that. Just to give you a quick sense of how much technology is in the car, it rivals space shuttles, aircraft, some of the most technologically advanced vehicles on the planet. For example, it's collecting 100 megs of data per lap, 600 terabytes in a race. There's over 300 sensors on the car, lots of telemetry, almost 1,500 data channels, 28 steering wheel sensors. So you can imagine the complexity when you've got all of these sensors sending data in real time during the race across all these channels, having to be ingested, computed, with models working on it in real time, not only to give feedback to the driver, but also to give incremental changes to the car so that it can shave milliseconds off every lap. The way they've done that is pretty key, but it actually isn't a technology story at the beginning. They've done something that we're recommending all people doing AI consider, and that's actually not siloing your AI projects in one department. And we see this happening all over the place. What they did early was create a center of excellence for AI. So Claire, who is the chief information officer, steward of all the data and the information, works extremely closely with Mark, who leads all the architects that are designing and implementing these solutions. And they work very closely with Stuart, who's the head of infrastructure. So together, they're looking at the data, the architecture that ties that all together with the models, machine learning and AI, so this is predictive and deterministic, and then the infrastructure team that's actually rolling that out. And what they've done is built a portable AI factory built on NetApp FlexPod. They've got over 20 GPUs running in a deployable kit. There's 2 of them. So one is in use at the current race. The others is being sent ahead to get ready for the next race. And that allows a very large team in real time to be able to leverage all the data coming in through those sensors to do optimization before the race starts, real-time optimization during the race, and then actually take all the learnings from each race and run that through all their AI models before the next race to make sure the car is set up slightly better than the race before. In another area where speed has a bit of a different component is in pharma. So here, their main challenge when they're trying to bring a new drug to market is that because these trials are so long, they can take many years, in some cases over 10 years, they're going through multiple refresh cycles. So their data has poor visibility, it's everywhere, it's in old systems, new systems, it's in the cloud, and their main challenge was they didn't have a high enough probability of success getting through the trials. So the vast majority were failing. So they came to NetApp and NVIDIA with that key challenge, is help us make sense of our data so that we can increase the probability that a trial will make it to market and reduce the OpEx in every one of those. So we were able to do that successfully. So that's 2 different examples of companies that got through that filter of the 85% that don't make it. And the reason I wanted to bring that up early is because we don't want to contribute to this narrative that the value is elusive. In fact, the value is massive if you can get through that data challenge. So how do you do that? Roughly speaking, to get an AI project complete, you've got to go through 3 unique phases. This is an oversimplification, but I want to make sure that we're speaking to all knowledge levels. The first is the preparation phase. This is where you're actually collecting all of your data, ingesting it, transforming it so that it's all uniform, loading it into the new platform. This is where 80% of the work takes place. And this is also the most critical place where failure happens. Why? Because this data is hybrid. It's across one or multiple clouds. It's on-premise. It's at the edge. It's everywhere. It's both structured and unstructured, which means it's not in the same format. It's across file and object. It's in data lakes. It's multimodal. And there's many copies of that data. All of this adds to an immense amount of complexity. So oftentimes, before you even get to use the amazing GPUs and all of that infrastructure, you're getting stuck here because you've got one, and in most cases, multiple challenges about how you can prepare that data. The next phase is a little more straightforward, but this is where we hear about these long training runs. For example, I think the last version of OpenAI's ChatGPT took close to a year to train on a massive cluster of almost 50,000 GPUs. Smaller models, of course, can take days and weeks, but this is where all the data that you've collected goes into the training phase to actually create the model. The next phase is where you actually release that to users. We call that inferencing, because the model is actually inferring what you're asking it and trying to give you a result. But if you don't make it to this inference phase, you don't have a chance at ROI. So think about that. We've got about 80% of the projects not even getting past the preparation phase. But now we know you can't even see value until you get to the inference phase. And that's what we're trying to help, is that more customers get through that filter of the preparation of data and can actually bring a model to production. How we're suggesting you do that is by looking at your data slightly differently. We call it intelligent data management. There's many different ways to talk about this, but a few questions you can ask about how intelligent your data estate is do you have a way to automatically discover your data wherever it may lie? And then once you've discovered it and found it, can you actually automatically classify it, or does that have to be done manually? If it is manual, it's going to take a lot of people, a lot of time. Can you automatically locate personally identifiable information? So you've got all of this customer data, which is rich and valuable to be ingested into your AI, but it's going to have email addresses, credit card numbers, all sorts of sensitive information that you cannot allow to get into that production model. So do you have a way to automatically locate that, mask it, and understand your compliance and your risk? Do you have a way to identify duplicate data, stale data that hasn't been accessed in 3 years? Is that relevant to the model that you're creating now? And do you have a way to facilitate migrations of data? So if you're moving data from your on-premise data center to the cloud, have you got a way to do that without creating a huge mess on both sides and potentially incredible amounts of egress and ingress fees? And most importantly, if you've already got a model, which most people do, whether you've trained it yourself, but more commonly, you're just licensing a model, like OpenAI's ChatGPT or Mistral or Anthropic, or even an open source model like Llama, do you have a way to identify which subsets of your data are best to use for your niche use cases using retrieval augmented generation, or Gen AI, more commonly referred to? Once you've understood how to manage your data estate, how are you thinking about the way you allocate budget to storage itself? This isn't the most fun part, but it is critical. Some of these production workloads will require sub-millisecond latency. Some of them don't have that type of precision required, but you've got to understand how to allocate your storage budget across your performance tiers to make sure that you're maximizing that budget. Of course, we would all like the fastest, the greatest, the highest performance, but you don't often need that for every workload, especially for things like backup and disaster recovery. So you've got to think about a way to start small and then understand how to have a linear scaling path so you don't bottleneck yourself. If you get that wrong in the early stages, the way that you can scale can change dramatically. You don't want to have an outage every time you need to add more storage or more compute. You've got to have a way to non-disruptively scale your infrastructure so that your operations are not affected. What about hybrid cloud? So we've talked about this a few times. It's very uncommon these days to see an organization using either only on-prem or only in the cloud. It does exist. What we see more commonly are organizations using either one cloud or multiple in conjunction with data on-premise. There's a lot of reasons for that. Maybe you have certain subsets of data that are highly sensitive, They have very high privacy demands. They just cannot leave your facility. Or maybe you want to use the cloud because it's got all the tooling, all the models, and your data scientists can collaborate very effectively. But when you go to productize that model, you'll bring it on-prem to harden it, secure it. There's a million reasons why hybrid is the most common workflow, but you've got to have a way to manage that without having to do a massive migration every time you want to move a petabyte of data from on-prem to the cloud. There's a few ways to do this. One is our operating system called ONTAP, which I said earlier is the only storage operating system that exists as a first-party service in Google, Azure, and AWS. What does that mean? It means that you've got the same control plane for your data estate, no matter where it is. So it's on-prem, if it's in the cloud, you've got, relatively speaking, the same tools, the same security, whether it's at rest or in transit. And that's a major efficiency generator in myriad of ways, including security, most importantly, in reducing costs in the cloud. But now that you're moving all of that data and introducing all sorts of threat vectors, you've got to think differently about security. It's probably not a surprise. This is a very popular message now, but the number one risk that we're seeing, according to a variety of surveys for businesses in 2025, is cyber incidents. The average one, I think the last thing I read was the average ransomware attack is costing between $6 and $8 million. We're seeing about a 75% increase year over year in ransomware attacks. This is a little bit different across the organization. But some of the things you've got to think about are, how do you actually scale and remain nimble and flexible without introducing security risks? In the event of an attack, how do you really quickly recover? How do you make sure that you're compliant and that your regulatory environment will stand up? Most organizations are aware that this threat is coming, and in some cases they've experienced it, but still, because this is a very unique skill set, the vast majority are reporting a skills gap. That's where you need partners at the networking level and at the storage level that can actually fill some of that skills gap. In the old days, security was already complex enough when it was just groups of people out there using tools and, of course, botnets and things like that. But now, in the AI era, ironically, AI agents are proving to be a very, very pesky threat vector as well. So there is a compounding issue here. While we all want to embrace AI, AI is actually causing a much bigger security challenge. So you might want the most secure storage on the planet. And there's going to be a few stories on how to measure that statement. It's a bold statement. But one that you could use is, for example, we are the only storage vendor that's certified and validated to hold top secret data. This is, one example is for the NSA, but we have a few stories in Canada as well, the DND. So for the world's most sensitive data, in a lot of the most highly secure environments, the only vendor they will choose is NetApp to store that data. There's a lot of reasons, too many to get into today, but a lot of this comes down to automatic identification of risks. In the event of an attack, having immutable snapshots of your data so that even if something gets taken, you're able to quickly restore to a version of that data that might be just 30 seconds prior to the attack. Things like multi-admin verification, so 2 keys to launch, that type of thing. The list goes on, but those are the things that go into that. And essentially, it's a framework. You've got to be able to protect your data. That starts, of course, at the network layer. So that's, your Palo Altos, your CrowdStrikes, Fortinets, all those types of things. But in the event that malicious actors get through that perimeter, your storage is the last line of defense, and that's where you've got to have a lot of technology in place to do that. And there's a new threat vector on the horizon. We've probably heard of quantum computing. It's been in the news a lot lately. It's not quite there yet. There's a lot of investment, a lot of promise, but it introduces an issue. If this new method for attacking our state-of-the-art today encryption one day becomes possible, there will be a new threat to think about. It's called harvest now and decrypt later. So for example, quantum can't crack your RSA encryption today, but malicious actors are thinking about tomorrow. when they could take your data now, and sure, it's encrypted, but later, when quantum is ready, it won't be. So even though this technology is not quite ready yet, we've got to be prepared today. And the rest of the world is thinking about starting this transition in a few years because it seems far away. Quantum, it's a theory. We're talking about dozens of qubits. There's only a few groups doing this at scale. Why worry about it today? But it's that reason. It's the fact that your data is encrypted today, it can be stolen today and decrypted later when this technology is ready. So we've decided to become quantum safe today. So with NetApp, your data at rest today is already what's called post-quantum cryptography ready. Our next version that comes out in December will also be PQC ready in transit. So if you put all that together, we've talked about three big categories. Modernizing your infrastructure, getting ready for a hybrid AI workflow, and then having a way to secure all of that data. What does it allow you to do? Does anyone know what this is? It's 256 GPUs inside of what's called an NVIDIA SuperPod. So these are the biggest AI factories that NVIDIA sells. They sell them in scalable units. This is one. Many organizations are buying multiples of these, in some case 10, 20, and building massive clusters of GPUs. They've got incredible demands in terms of the speed that you can feed the data to them, the security, the governance. And this goes back to the very first slide we talked about with Jensen. There's some pretty extreme performance required for this. So we're talking over a terabyte per second, 40 million IOPS per second, a lot of speeds and feeds. I won't go into all that today. But NetApp has recently been certified to power SuperPods. Is everyone in this room going to go back to their own organization and suggest buying a SuperPod? Probably not. But it's like saying if the seatbelt is good enough for the Formula One car to protect Lance, it's going to be good enough for the cars that we drive. There's a few things you have to look at when you're building an on-prem AI factory. Of course, you can use cloud GPUs. There's some advantages. There's some disadvantages. But we see a bigger trend these days of building this on-premise. The three things you got to think about is, we've just invested in all these GPUs and networking. Are we going to bottleneck ourselves because our storage isn't fast enough to keep those GPUs saturated? Great. You have 256 B200s, but now you're bottlenecked because you're running on 10-year-old storage that can't feed them. That's not a good situation. So the ROI of an investment in GPU infrastructure goes up when you have the right storage. The end state that you're trying to get to is an end-to-end pipeline that allows your team to use one consistent platform all the way from ingesting data, preparing the data, training the data at scale, optimizing that for inference, and then of course doing your fine-tuning and retraining, and deploying that at scale. That takes a lot of different skill sets, a lot of different technologies. We think we've got some of the best in class to help you with that. We've got a huge team here, and we've just announced a couple of new offerings yesterday. Because it was hot off the presses, we couldn't fit it into these slides. But essentially, you can go to NetApp.com and read about the big announcement that came out yesterday, which is a global metadata namespace. It's a fancy way of saying now you can unify your entire data estate on a single namespace, no matter where it is. It's too much to get into for this talk, but if you're interested in learning more, we've got a bunch of people at the booth out there, and we'd love to chat more about that. Essentially, it allows you to connect AI to your data, we think, like no one else. And there's a lot of ways that we think we can prove that and stand behind it. Thanks for your time today. Hope to see you outside.